So if you keep x, differentiate y equal to x, you have y squared dy dx. You just rewrite your y square and put dy dx, because this is a function of x and not y. Plus, you now keep this y, differentiate x related to x. You have 1. You close it. We are done with this first part, the first term. So go back to the second term. Minus, you keep 3 outside. Keep v. Keep u. X cube. Differentiate this related to x. You have y dy dx. Plus, keep this differentiate this related to x. You have y 3x squared. Recall your normal method of differentiation using power rule. We use this the power to multiply the base and you subtract 1. So when you have y equal to x for n, then your dy dx is equal to, use the power to multiply the base, you subtract 1. So that's what we did here for this. That's what we did. Remember, you have your 3 outside. So use this 3 to multiply what you have here. Then subtract 1, 3 minus 1. We also did the same thing here. Yeah, we also did the same thing here for x. Because x, if you have x, so x having the stable 1. To find the derivative of this, you have to use this one to multiply this, and so also subtract 1. You have x power 0. And anything raised to power 0 is 1, right? From basic law of indices. So we simplify further. Before you simplify further, you have another thing here. You have a constant. If you differentiate the constant, you have what? You have 0. So here you have 0. You simplify further. You use this 5 to distribute into what you have into this parenthesis. You do the same thing. You use minus 3 to distribute what you have into this parenthesis. Right? So if you do that, you have 5x y over 2 dy dx plus 5y squared minus 3x squared cube